Hi everyone, I'm William Nash with Vargus. Welcome back to Pump Shaft Machining, Part 2 at Harper College. Today, we'll be covering the milling operations for this pump shaft, including cutting the splines, the indexing flats, and the keyways. We'll be working here on this Haas VF2, utilizing 100% Vargus tooling, including our shell mill adapter for milling and spline cutting, with these inserts, and Vargus V-mill. And then we'll have Aaron come out to run the machine.
Hi, I'm Aaron. I helped out during the first video. Here we are at the second video. We're going to do milling on the pump shaft. The first tool is going to be a 10mm end mill, and we're going to be doing some indexing flats. Tool number 2 is going to be a 2mm diameter end mill, and we're going to mill some keyways. So the final operation is going to be our last tool, which is going to be our shell mill style holder, and we're using that with spline cutting inserts, and we're going to cut 6 splines on the end of the shaft. So we were over on the splines, and we moved the diameter offset on the cutter. We're going to run that again and see if we're within tolerance. That finishes up our first part. We kind of did some test cuts on it and made sure everything was okay. We have one more part to run, but we dialed everything in, made sure everything was in tolerance, and we're going to set the second part up, and we're going to run that, and hopefully we'll have a good result with that.
And while Aaron sets up the second part, I'll take you in the other room. We'll show you on the computer what we did for the programming. During this process, we used hyperMILL to program the lathe behind me. We also used hyperMILL to program the milling toolpath. There was one operation, the spline mill cutting, that we did not use hyperMILL for. And it's not their fault. We would have used them if we could have. But I had an issue on my PC, so that we had to do by hand. 2 of the 3 operations that were programmed by hyperMILL. And I'll take you through all 3, including the manually programmed operation here now. For the first operation, we have our 10mm end mill, which is the VMSC 250 Z4 C10G VM9. For the operation itself, I will copy that into a viewer so that you can get a look at the toolpath. So here's our toolpath for the slot milling application. As you can see, it's quite simple. We step down and over to the part, across, get ready for our second cut, across. Here we would rotate C, step down and over to the part, cut across, one motion, everything is done. Then, for our second operation, we're using a 2mm end mill, VMSC-002C060-Z4C04G-VM9. So here you can see we're also slot milling with the 2mm end mill, but we have a different style. We will bring the tool down into the material, arc on, and work at an angle to one side of the pocket and then the other until we achieve full depth. The shell mill operation or the gear milling operation, unfortunately, I'm not able to simulate for you because we wrote a small macro. So what you'll notice here that you didn't see in the other code is that there's a few variables that we're setting. We're setting a variable for the counter, for security positions, for the diameter of the part and the finished diameter, the number of lobes, and then actually the feed rate of 3 thou feet per tooth on the spindle RPM and the number of teeth. Then we go through and we use those variables in a while statement, saying while the variable for the counter is less than the number of lobes, we're going to do the operation. So we go through to a safety position, we plunge into the material here, then we cut to the length that we need, we come out to a safety position, we increment the counter and we rotate A, and so long as this condition is true, we keep repeating this statement until the spline is finished. Then we cancel our cutter compensation and home the machine.
All right, so we have the second part set up and we're ready to go. So we're gonna hit cycle start and see what happens. All right, so we'll measure this part up. Everything ran fine, and I'm sure we're gonna end up with a good part.
So once again, we brought back this part to the Alicona headquarters and measured it on our Infinite Focus G6 device, where we were able to capture 3D data sets of the new features. If we take a look at the key slot data alone, we are able to see that the width across is about 3 millimeters, 2.9924 to be exact, and we constructed a line using our focus probing technology along the left side and mapped across to the sidewall to get that measurement. Then we were able to draw a profile along the long side of that key slot and we found out that the length of that is about 19 millimeters. And then if we take a look at the depth of that feature, it is about 1.19 millimeters deep. To measure the index flat, we took a similar procedure as measuring the key slot feature. First, we took a profile across the width of this, and it came out to be about 5.95 millimeters wide. Then similarly, we took a profile across the length and found that the length is about 10 millimeters long. For the final depth of the index flat, we used our height step measurement in the lab measurement module and found about 0.4 millimeter depth. The last measurement we took a look at was of the curved spline features on the end of the shaft. Once again, we cut a profile form across, and the best way to kind of see the difference in depth between the two surfaces was to fit two separate circles and then take a look at the difference in radii. And that difference came out to about 1.08 millimeters.
Hi, this is Dennis Spaeth, publisher of Cutting Tool Engineering. Hope you enjoyed the video where we were milling the pump shaft for this project that we're doing with Harper and Vargus. We'll be discussing this at length in our Bourbon with the Editor podcast, which you'll be able to access in the description below. You just click on the link.